Alright, so we've got new stuff on tabular integration today. I'm going to quickly review integration by parts. Um,
Mm-hmm.
Integration by parts we get from product rules. So if I had uv equals u prime v plus uv prime for my derivative, I could integrate both sides. When I integrate the derivative on this side, that will cancel, so I'm end up with uv. On this side, I've got the integral of u prime v plus uv prime. Because I'm integrating and I'm adding, I can split this up into two separate integrals. It's got the same bounds. And then I can move one side over to the other. So this would be the integral of uv prime, if I leave this one on the side, would be equal to uv minus the integral of u prime v. Okay, so that gives us our normal integration by parts formula. The cool thing about this formula is we're always deriving the u, but we never have to derive the v part. And we're never integrating the u part. So what that means is if we have a part of our function that we don't know how to integrate, integration by parts might allow us to integrate that whole function regardless. So we've got a priority listing here for what we should use for u of x, the part that we derive, with the acronym ILATE. So if you see an inverse trig function, that should be a priority for what you derive. Then logarithms, polynomials, algebraic functions, trigonometric functions, and then exponential functions. Okay, so here's one worked out the old way. If I wanted to integrate natural log of x dx, then I could derive the natural log and integrate the dx. So this would be uv, so if I integrate dx I get x, so this is x ln x, minus u prime v, minus 1 over x times x, which is 1, and if I integrate 1 I get x. So that's x ln x minus x plus c. Okay, I've seen you do this part before, but any questions on integration by parts?
Nope.
Okay, then the new stuff for today. Before I jump into it, we've got different integral notation. Different integral notation is another way of writing functions. So it just says we're going to derive this function q amount of times. So I got this weird double d here, which just means we've derived it q amount of times for whatever our function is. If q is negative, then that means instead of deriving, we have integrated it that many times. So I could say in different integral notation, d3f would be the third derivative of f. d negative 2f would be a multiple integral, so you integrated f twice.
Mm-hmm.
Okay, so with that, if I wanted to take our general form for integration by parts in different integral notation, then I could write it like this. The integral of uv prime would be equal to uv, so that's the first integral of v prime, minus the integral of u prime v. So that's the first integral of v prime again. Okay, so if I keep integrating for the rightmost part, I would do the exact same process. And if I keep expanding this, you'll notice a pattern. So when we're integrating by parts, after I simplify everything out, I end up with u d negative 1 v prime minus u prime d negative 2 v prime plus u prime prime d negative 3 v prime. So my signs keep alternating, positive, negative, positive, negative, positive, negative, if I keep expanding this. I keep deriving my u term one more time, and I keep integrating my v term one more time. Okay, do you see the pattern?
Yeah. It's minus, plus, and yeah, I see pattern.
Okay, keep deriving u, keep integrating v prime. So what that means we can do is I can set this up as a table. So this is called Tabular Integration. So I'm going to start with our original function.
Mm-hmm.
And I'm going to derive our part we need to derive and integrate the other part. So whatever you choose for u, you're just going to drive down. Whatever you choose for v prime, you're going to integrate. So this is u, and this is v prime. This will be the first integral, the second integral, the third integral, etc. This is my first derivative, second derivative, third derivative. Okay, so once we got our table set up, I'm going to match each of these functions diagonally. So I would need to multiply u times the first integral of v prime, so that's uv for my first term. Okay, so here's x squared negative cosine x, uv would be my first term. Okay, my second term would be the next derivative and the next integral, so I'm going to match those two. So just keep matching diagonally. Okay, then we also need to look at our signs. Our signs will always start positive, negative, positive, negative. So this will be positive x squared times negative cosine x is negative x squared cosine x. Okay, minus 2x times negative sine x. Minus a negative is positive, so that's positive 2x sine x. Plus 2 cosine x. Minus 0. Now everything after this will be 0 times a number, so at this point we're done. The integral of x squared sine x dx is equal to this. Okay, any questions on what we did?
Nope.
Okay, cool. I didn't have my plus c there, so I just wrote that, but plus c. Okay, so I'm going to look at one free response question involving integration by parts, and we'll see if we can do it the new way. Again, if it's blurry, this is the 2008 file that you saw. Okay, the derivative of our function is given by f prime x equals x minus 3 times e to the x for all values where x is positive, and f of 1 is 7. Okay, first, we've got a critical point at x equals 3. At this point, do we have a relative minimum, maximum, or neither? And justify your answer.
So it's with f prime 0, it's relative maximum.
Okay, so you set this equal to 0. 0 equals x minus 3 e to the x. What would we have to test in order to prove it?
So x equals 3, and then we make a graph.
Okay, so when x is less than 3, what happens to f prime x?
That's negative number. Oh, that's positive. So it's relative minimum.
Okay.
Is relative maximum.
Is it relative maximum or minimum?
Minimum.
Okay. Any questions on our justification?
Nope.
Alright. Then I want to know what intervals would the graph be decreasing and concave up, and explain the reasoning. So what else do we need to do to prove it?
Oh, oh no, in derive again.
Derive one more time. Okay. So I'm going to copy our f prime here. This is x minus 3 e to the x. We already did our first derivative test up here, so I'm just going to do the second derivative test down here, and we'll compare them. So first, what happens when I derive this?
So that's x minus e. No, that's just x. No, it's 1. E to the x plus x minus 3 e times x power. E to the x power.
Okay, and can you simplify?
So that's x minus 2 e to the x power.
Okay, so for concavity, we're going to set this equal to 0.
So x is 2.
Okay, so I've got a breakpoint at x equals 2. If x is less than 2, what happens?
That's negative number.
Okay, and if x is greater than 2?
That's positive number.
Okay, so I've got our second derivative test I'm going to draw up here.
So
Actually, I guess I will draw both of them. So our first derivative test said if we were around 3, we were changing from negative to positive. Our second derivative test was about 2. Okay, so I wanted to know, where are we decreasing and concave up? Okay, so I am decreasing when I am less than 3. Not included. And I am concave up when I am greater than 2. So what's my overlap?
2 and 3.
Okay, we are decreasing and concave up on the interval what?
2 and 3.
That's 2 points. I need an interval.
Into decreasing, but 2 to 3, isn't it?
2 to 3. Okay, so that's 2 is less than x is less than 3. As f prime x is negative, is less than 0, and f prime prime x is positive. Okay, any questions on this one?
Nope.
Cool.
Wait, is it BC question?
This is a BC question, yeah.
It seems easy.
So far. Okay, last one. I want to find the value of f of 3.
Oh, so we integrate.
So I'm going to integrate. So let me write down everything we were given really quick down here. So f prime x, we were given is x minus 3 e to the x. I was told
And
f of 1 is 7, and I want to find f of 3. Okay, what do we need to do?
so we integrated. We have to do U and V thing, right?
Right, so I'm going to start with what I was given. So I'm going to start with uv prime. This side I will derive, and this side I will integrate. Okay, so starting with what I was given, which part is u?
U is e to the e. No. X minus 3. So we have to derive it and get 1.
Okay. So when I derive it, I'll get 1 dx.
Yeah,
When I integrate e to the x, I'll get...
e to the x.
Okay, when I derive dx, I'll get...
0.
When I integrate e to the x, I'll get...
E to the x.
Okay. So then I'm going to match these. So these two terms will go together and these two terms will go together. And we always start positive and alternate signs. Okay, so what should our final answer be for the integral?
So x to the minus 3 e to the x minus dx.
Minus...
Wait. E to the x ex dx.
E to the x dx. Okay, so I'm just multiplying these together. X minus 3 times e to the x minus 3 times e to the x, minus e to the x dx, e to the x dx. Okay, so this is my integral. So if I wanted to figure out what f of 3 is, and I know f of 1 is 7, what would I have to do?
Wait. So x minus 2 e to the x is our integrate, right? If we simplify it. No, x minus.
If I simplify this, this will be x e to the x minus 3 e to the x minus e to the x. So that'll be x e to the x minus 4 e to the x.
And then yeah, plus c. We plug in 1 to find c.
So I actually don't think we'll need to find c, because we'll need the bounds for this one. If I know our start point is 1, 7, how can I get from 1, 7 to where we will be at 3?
2?
There's a difference in x of 2. Okay, I'm going to take my start point, and I'm going to add the integral, so how much we changed
Oh,
in my
0
y
to
value,
2.
right?
Yeah.
From what to what?
1 to 3?
1 to 3 of... Okay, f prime x dx. Okay, so my start point is 7. And I'm going to add the integral from 1 to 3 of our function, which is, since we already integrated here, this will be...
Or we can use calculator.
x e to the x. I don't think there is a calculator in this section, so we can't use a calculator, but that's okay, we don't need one. Okay, so what do I do next?
Plug in the numbers, so 7 plus 3x to the third power
3e to the third power?
minus 4 e to the third power minus 1 e to the first power minus 4 to the 4 e to the first power. And then we simplify it. So 7 minus e to the third power.
Okay. Here had to be e to the third power. Okay.
Minus plus 3e.
Okay. Okay, so this is okay, that's good. I want to take a look at this step we had trouble with though, really quick, just to be sure. So my general form for this was if I want to get to a new y value, I'm going to start at a previous y value, so in this case f of 1, and I'm
Mm-hmm.
going to add the change in my derivative. Okay, any questions on anything?
Nope.
Awesome. So I do have a link up on course sites this time. I realize I forgot to put course links up previously, which is why you've been sending me stuff on WeChat, I think.
Mm-hmm.
So course sites link is up. I'm going to take this one as a quiz grade. I've got a general integration quiz this time.
Oh wait, in course site?
Yep. So I gave you the copies of the quiz on WeChat and Skype. So if you can't access course sites for any reason, then you can do what you've been doing. But
Mm-hmm.
ideally, send me a copy on course sites, and that will save forever. Whereas Skype and WeChat sometimes get rid of them after a couple days.
Wait, tabular, this is FRQ was classwork that we did. Oh, integration test.
Right.
So this is my homework.
It's homework. It's going to count as a quiz grade, though.
It's a
Um,
lot.
so there's a couple problems. I think there's 15 multiple choice and 3 long form.
Mm-hmm.
Okay. So that's going to be due on Wednesday at 9
Mm-hmm.
a.m.
Yep.
And then that'll be it for today.
Mm-hmm.
All right. Thank you very much.
Thank you. Bye bye.
Goodbye.